So today I'm going to talk about regular expression pattern assignment where I have 5 sets of problems. So the first problem is email validation. So for an email to be proper, it must have a username followed by @ symbol followed by a proper domain name. So let's go over the regular expression pattern. So the first, we check for instance of word characters along with period, which can have one or more characters. Next, it is followed by @ symbol, and after that we check for the letters, which can have one or more instance, and after that we check for period, and after that we check for letter which has 2 or 3 characters. So this is the code I have over here, and this is the example for the test case. So let's go over the first one, john@example.com, which is a valid email. So I have run my code over here and it says it's true. And this is invalid according to my regular expression, and I wanted to keep my expression simple. So jen@example.co.uk should be invalid, which is invalid. Invalid at email should be obviously invalid. And we have another .invalid@email.com, which is valid according to our regex pattern. So it's true. And this should be invalid. So it is invalid, which is false. So the next up we have phone number. So for a phone number, there must be area code. So area code is something like 01 or +1, which is followed by 3 more digits. And after that there's 3 more digits, and after that there's 4 more. So first we check for plus sign, and then we check for 2 more digits after the plus sign, followed by space, which is optional, and all of this is optional. And then we check for opening bracket, which is optional, and then 3 more digits, and then a closing bracket, which is also optional, and space or dash, which is optional, followed by 3 more digits, followed by space or dash, which is optional, followed by 4 more digits. So these digits are grouped just in case we might need them later, because this acts as area code. So we can later use this as an area code of the phone number. So this is a test case I have. This is a valid phone number, which is true. So this is also valid, and this is dash, and this is bracket separating the 3 digits. So which is true. Our code also checks for this, which is really good. So this is also valid phone. Oh no, this is invalid because there's 5. Yep, invalid. So this is valid because of the country code. True. This is also valid, which is true. And this is invalid because there's true. There should be 3 and there should be 4 for it to be valid. So this is false. So next up we have tag removal. So this is the easiest of the all problems, because all we have to do is find an opening angle bracket and copy everything or match anything and everything that is within the next angle bracket. So there can be 1 or more instance, and then we find an instance of closing bracket, and the flag we have is global flag, which matches all the occurrence, and we have case insensitive flag. Okay, so now we have a function that takes the string with the HTML tag and returns another string that removes the HTML tag. So let's go over this test case. So this is a bold text. So one point to note is that it also works with a nested loop of tags. So it should only return this is a bold text without the p tag. And this is it. This is a bold text. Heading, this is a link. Heading, this is a link. So there's no HTML tag here, so it should be written as is. No HTML tags here. So this is emphasized. This is emphasized, and this is italicized text. This is italicized text. Okay, next up we have your parsing. So this is the most difficult problem of all. So we have a function that takes a string and it returns an object which goes like this. So this is the return type. So over here we have protocol, we have domain, we have port, we have path, we have query, and we have the hash, which is in the rest, right? So for the protocol, we check for the HTTPS or FTP, and then we check for trailing slash, and then after that we check for domain name until the symbol, I mean colon symbol, then because after colon symbol we have port, and then after the port, if we have trailing slash, and port is also optional over here, and if there's trailing slash, capture everything till there's a question mark, right? So that is the path, and after the question mark is query, and after the hash there is the rest part, rest of the everything of the URL, which is the hash. So this is what I'm returning. So let's go over our first example. So this is the protocol. HTTPS example.com is the protocol. This is the path. This is the query. This is the query, and this is the hash. So in the object we have correctly identified the domain. We have correctly identified the path. We have no port, so it is empty. We have correctly identified the protocol. It is HTTPS. We have correctly identified the query, and we have correctly identified the hash. So in this example.com, we have correctly identified the port and the protocol. So over here in this example, also we have correctly identified the path and the protocol. So this is the most simplest example. Everything is correct, and since this is an invalid URL, our program returns null, which is correctly identified. So the last step we have is the credit card masking. So what credit card masking does is, if we have to display a sensitive information of the credit card for the user to verify if it's theirs or not, so we only show the last 4 digits of the credit card, but for this purpose I have been showing the first 4 and the last 4 digits of the credit card to the user. So over here we capture the first 4 digits and the last 4 digits of the credit card, and then we mask everything else. So in this instance, the first 4 is 1, 2, 3, 4, and the last 4 is 3, 4, 5, 6, and the rest is X'd out. This is the first example. The second example is 4, 1, 1, 1, and the last 4 is 1, 1, 1, 1. So everything in between is masked. So in this third example, since there's no need to be masking, there's not enough number, it is not masked. In the third one, we have the first, everything is 0, so the first for a group of 0 and the last group of 0 is shown. Similarly, 9876 and 6543 is correctly shown. So this makes up my demonstration for this project. Thank you.